All right, get ready for this, because we're about to connect two worlds you probably never thought belonged in the same sentence: hip hop and algebra. We're going to see how one of the biggest names in music can actually help you understand one of the most fundamental ideas in math.
So, what in the world does a J. Cole song have to do with a linear equation? Sounds kind of out there, right? A track from an album and a line on a graph. Well, the answer has nothing to do with the numbers in his lyrics. It has everything to do with the pattern. A pattern you can literally hear and feel.
So here's how we're going to do this. We're actually going to start with the music itself to get a real gut feeling for a core math concept. And trust me, J. Cole's signature style, it's the perfect key to unlocking this whole thing. Think about it. How does a classic J. Cole song really work? He's a master storyteller, right? He doesn't just, bam, hit you with explosive energy from the first second. No, instead he builds his case bar by bar. The energy, the intensity, it all increases so steadily, so evenly, without any of those sudden, jarring changes. That feeling of a consistent, predictable buildup, that's the feeling of linear growth.
Okay, so we've got the vibe, right? That feeling of steady growth is locked in. Now, let's get a little more technical. We're going to translate that musical idea straight into the language of math. We're basically creating a map from the song directly to the equation.
Check this out. Think of this table as a Rosetta Stone for translating music into math. Each bar that passes in the verse, boom, that's our x value, the independent variable. The amount of energy he's adding with each one of those bars, that's our y value. And here's the crucial part, the absolute key. He adds the same amount of energy each time. That's what we call a constant rate of change. You put all that together, and that steady buildup is what we call a linear relationship.
We've mapped out the concept, but now let's make this thing real. We're going to take this idea of adding the same amount of energy per bar and actually see what it looks like when we put some numbers to it. Take a look at this table. It's super simple. After bar 1, let's say the energy level is at a 2. Then after bar 2, it's at a 4. After bar 3, it's a 6. You're seeing the pattern already, aren't you? For every single bar that goes by, that's our x, changing by 1, the energy level, our y, goes up by exactly 2. That +2 right there, that little number is everything. It's the musical secret, and it's the mathematical key. It's not +2, then +5, then back down to +1. Nope. It's +2 every single time. This consistency, this predictability, is what we officially call the constant rate of change. And here it is. This is the big reveal, the aha moment. When you take those points from our table, 1, 2, 2, 4, 3, 6, and you plot them on a graph, what do you get? A perfectly straight line. And why is it straight? It's straight because the change, that +2 we just talked about, is constant. The straightness of the line is just a picture of the steady energy in the song. So we've heard the pattern in the music, we've seen it laid out in a table, and we've seen it visualized on a graph. Now it's time to give this whole behavior its official, fancy math name and look at the formal definition. And here it is. It's really that simple. A relationship is linear if it changes by the same amount every single time. That's it. See? It's not about some scary, complicated formula. It's about a consistent behavior, just like J. Cole adding that same amount of narrative energy with each bar he spits. So this means you can spot this pattern in a few different places. If you're looking at a table, you're going to see those even jumps, or +2. If you're looking at a graph, it's going to be that perfectly straight line. And yeah, if you're looking at an equation, it'll take that form y = mx + b. But all three of those are just different ways of describing the exact same thing, that steady J. Cole-style growth. So you might be wondering, why go through all this trouble with a music analogy? Well, here's why it matters. Anchoring this math concept to something you can actually feel, like that steady build in a song, is probably the best way to avoid some really, really common mistakes. Let's break down some of those myths. So many people just say, oh, linear just means a straight line. But the J. Cole fix reminds us why it's straight in the first place. It's because the energy added per bar is constant. Or the myth that slope is just some formula you have to memorize. No way. Slope is the amount of energy being added each bar. In our case, it's our +2. And finally, not every table of numbers you see is linear. Just ask yourself, does the song suddenly explode with energy out of nowhere? If it does, that's not a J. Cole track, and it's not a linear table. If you walk away with just one thing from this explainer, let it be this. Linearity is a behavior. It's a type of change. It's about that steady, predictable, constant growth. And you know what? Understanding that behavior is infinitely more powerful than just memorizing the formula y equals mx plus b.
So, we'll end on a question for you to chew on. If J. Cole's methodical, bar-by-bar storytelling is a perfect picture of a linear function, what kind of artist, what kind of music represents an exponential one? Where the energy doesn't just add up, it multiplies and explodes. Think about that.